Hi everyone, my name is Sarthak, your study helper. Today we are going to be talking about the experiment known as balloon rocket experiment. So, if I'm going to give you a simple but detailed explanation, but if you want the full and more detailed explanation, you can pause the video and read the purpose hypothesis from the screen. Let's start. So, the purpose is that the core purpose is to illustrate Newton's third law of motion, which is for every action there's an equal and opposite reaction. This is seen as air is expelled from the balloon, which is known as the action, and propelling the balloon forward, which is the reaction. Demonstrates key physics such such as like thrust, the force the balloon moves, and the experiment also shows pressure at work, as high pressure air inside the balloon escapes to the lower pressure outside environment. It visualizes energy conservation, transforming potential energy, which is stored in the balloon, into kinetic energy, the balloon's movement. Ultimately, it provides a hands on understanding of how forces interact and the principles behind rocket propulsion. Hypothesis. When air is rapidly expelled from an inflated balloon, it generates a propulsive force called thrust. This thrust acts in the opposite direction to the escaping air, causing the balloon to move forward along a guided path. And now, let's go to hypothesis. The hypothesis is when air is rapidly expelled from an inflated balloon, it generates a propulsive force called thrust. This thrust acts in the opposite direction to the escaping air, causing the balloon to move forward along a guided path like string. This directly proves Newton's third law. The action is air rushing out backwards, and the reaction is the balloon being propelled forward by an equal force. The forces, the speed and distance the balloon travels depends on the volume of air in the balloon and how quickly the air escaping the string helps to stabilize the path for easier observation. And now let's move on to the materials, which are a balloon, a straw, a string, some string, some tape, a ruler or scale. This word is based on region. The procedure is first, stretch the string across a room or space, like stretch the string from point A to point B. Then, thread the straw onto the string. That means insert the straw into the string or onto the string. Step 3. Inflate the balloon, but don't tie it, just pinch it closed. Step 4. Tape the balloon to the straw. Step 5. Let go of the balloon and watch it move along the string. And now let's go to the variables. The variables are independent variable, amount of air in the balloon, dependent variable, distance the balloon travels, control variable, control variables, size of the balloon, type of string, and angle of the string. The questions are: how does the direction of the air escaping the balloon relate to the direction the balloon moves? What effect does the amount of air or inflation level in the balloon have on the distance it travels? Question 3. How is the movement of the balloon rocket similar to how a real rocket launches into space? What forces are acting on the balloon rocket as it moves along the string? Question 5. If you want the balloon rocket to travel even further, what changes could you make to your setup and why? These questions are answered by when we get the results or by using the hypothesis combined with the results. And here are the pictures I took. And here is the result table or charts, tables or graphs. The balloon moves along the string and the distance it travels depends on how much air is in the balloon. More air makes the balloon travel further. I will explain the definition of balloon diameter, balloon length, distance traveled, and time taken. The definition of balloon diameter is widest part of the balloon, balloon length, longest part of the balloon, distance traveled, how far the balloon went, time taken, how long it took to go that far. I took 5 trials just for this experiment. Balloon diameter. Trial 1. Balloon diameter was 9.5 centimeters. Balloon length was 20 centimeters. Distance traveled was 1.2 meters and time taken was 3 seconds. Trial 2. Balloon diameter was 10.2 centimeters. Balloon length was 22 centimeters. Distance traveled was 1.5 meters and time taken was 3.5 seconds. Trial 3. Balloon diameter was 8.9 centimeters. Balloon length was 18 centimeters and distance traveled was 1 meter and time taken was 2.8 seconds. Trial 4. Balloon diameter was 11 centimeters. Balloon length was 25 centimeters. Distance traveled was 1.8 meters and time taken was 4 seconds. Trial 5. Balloon diameter was 9.5 centimeters. Balloon length was 20 centimeters. Distance traveled was 1.3 meters and time taken was 3.2 seconds. Now let's move on to the conclusion. The conclusion is that the experiment successfully demonstrates Newton's third law of motion. As air was released, action, the balloon moved in the opposite direction, which is the reaction, propelled by the escaping air. Observations showed that factors like the amount of air, the size of the opening, added weight, and the string's angle all influenced the balloon's speed and distance. This highlights how thrust, mass, and external forces like gravity affect motion, providing a practical understanding of propulsion. And the name of yours and the teachers, made by Sarthak. And these are some of the teachers which helped me in my other science fair projects. Thank you for watching my video. Hit the subscribe button down below and click on the like button and describe how you like the videos. And if you want, if you didn't understand some topics, just comment down below and I will let you know. Thank you guys for watching my video. Bye.